Hey, this is Mrs. Harris, and we're going to be talking again about how to solve quadratic equations that do not have a 1 as a leading coefficient. So here we have 2x squared minus x equals 21. So before we can start working with this quadratic equation, we're going to take the 21 that's on this right-hand side, and we have to go ahead and move it over to this left-hand side. So how are we going to do that? We're going to go ahead and subtract 21 from each side. 21 is a constant term. So when we rewrite this, it looks like 2x squared minus x minus 21. And that will equal 0 because now there is nothing left on this right-hand side because 21 minus 21 gives you a 0. All right, so now we have to say that a times b, which is 2 times negative 21, which gives me a negative 42. I need to find factors of 42 such that when they're added together, give me a negative 1, because that is the coefficient of the middle term right here, where x is raised to the first power. So I need to find factors of negative 42 that when added or subtracted give me a negative 1. All right, so let's go ahead and make our factor tree. So I'm going to go ahead and start out with 42 and 1. Well, I can make it such that they give me a product of 42, but there's no way I can rearrange 42 and 1 to give me a negative 1. So that's not going to work. All right, so let's look at another factor. It's even, so it's divisible by 2, so it's 2 and 21. Okay, well, 2 and negative 21 certainly do multiply out and give me a product negative 42, but there's no way I can manipulate 2 and 21 to give me a negative 1. Not going to work. Let's see. I'm going to try 6 times 7. Now this looks really good because I know 6 times 7 will give me a product of 42. And if I take negative 7 plus 6, it gives me a negative 1. So it looks like it's going to work. But I need to make this a negative and this a positive. So we're going to use that really neat trick again of rewriting negative 1x in terms of 6x and negative 7x. So let's see what that would look like. So here we have 2x squared minus 7x plus 6x minus 21 is equal to 0. Okay? So now we can see that negative 7x plus 6x does give me a negative 1. So I need to combine these to group them. Now, I don't want to group 2x squared and negative 7x squared because I can tell that they're both prime and they don't have anything in common. But I could group negative 7 with negative 21. They have something in common. And 2x squared and 6x have something in common. So my grouping is going to be 2x squared plus 6x. And then I'm going to have negative 7x minus 21, and that equals 0. So I'm just rearranging the terms that you already have here. I'm just switching around, which I can because addition is commutative. So I'm going to go ahead and take 6x over here because 6x minus 7x still gives me a negative 1. So this is my group, and this becomes my group. So what is common between 2x squared and 6x? Well, they both have 2x in common, so 2x. So what do I multiply 2x by to get x squared? An x. What do I multiply 2x by to get 6x? A positive 3. What do negative 7x and negative 21 have in common? 7 goes into both of them. Okay, and I see here that I have an x plus 3. So I want to make sure that I take out a negative 7. A negative 7. So negative 7 times, what do I have to multiply negative 7 to get me a negative 7x, it's x. What do I multiply a negative 7 by to get me negative 21? Positive 3. So you can see here that both of my terms now share the common factor of x plus 3. So I'm going to factor that out, and then I'm going to group together the two things that are left. So it's x plus 3 times 2x minus 7, and that equals 0. So now we have actually factored the quadratic equation 2x squared minus x equals 21 into x plus 3 times 2x minus 7. We have factored those. All right, so now we know we find our roots that x plus 3 has to equal 0 and 2x minus 7 has to equal 0. So I'm going to subtract 3 from the side, and we see that x equals negative 3. So that's where a root should be. And we're going to add 7 to each side. 2x is equal to 7. And again, I don't want 2x equals 7. I need to just have x. So I'm going to divide both sides by 2. And I get x equals 7 over 2, which is 3/2. So my solutions, the roots, the x-intercepts of where this quadratic crosses the x-axis can be found at x equals 3 and x equals 7/2. All right, so again, that's how we are going to solve a quadratic equation that's given to you where the leading coefficient is not a 1 or a negative 1. All right, so we got the factored form and we have our roots. All right, thanks.